Hi, welcome to the ZP Developers Zone. So we do this every Thursday at 8 a.m. London time, and we always try to do this live. Now, unfortunately, I'm in a pretty poor internet connection location today, so unfortunately, we will be recording this and then uploading it. But as I say, I like to do it live. It's more spontaneous. We get nice feedback in real time. So my apologies for that. First things first, we always put this slide up. If you've got any technical questions around electrochemistry, don't forget the ZP Developer Zone, and there you can find a couple of, for example, free courses. We do webinars. So, for example, we do webinars with academia. We did a nice webinar this Monday with South Dakota State University, and I'm really grateful to them and thankful to them. We do collaborations. It's probably worth saying that we've also had an intern start this week, and I'm really pleased with their progress. So thank you very much. We've also got our ZP Developer Zone website, and we also have workshops. Now, on the workshop front, we've become a lot more active over the last few months because things are really, somewhat returning to normal. So some workshops that are coming up. We do have 2 workshops in India. We do have a workshop in San Diego on the, I think it's on the 8th of November. We do have, it's actually on the 10th of November, we do have a workshop also in Horton on the 30th of November, which is in Norway. We do have a workshop in Coventry on the 8th of December, and we do have a workshop on the in Grenoble in mid-December. So we do have quite a few workshops coming up. And I'll try to put some links underneath the video later on. Now, I had a couple of questions this week. One of them is for testing the presence of blood, and the other one is the process to manufacture a biosensor. So I'll go quite quickly through this. So we do have a technology for detecting blood. Even if it's not for the quantification of blood, we can actually quantify blood. The quantification of blood is in part based on our kind of Sense It All platform. So we do have a stack of technologies that we call Sense It All, and Sense It All platform, for example, has sensors in it or electrodes in it. We have electronics in it. I'll show you that the electronics are not limited to this form factor in a minute. We obviously have app developments. I think at ZP we like to put an app into everything because an app is both a nice screen. It's a very functional device, often a smart device, so they can be very useful to us. And they're also a kind of a nice bridge between the electronics and the cloud, because then the last bit then, in some ways, is the cloud itself. So if you want to detect blood, for example, then we would use we can use one of our electrode systems. We can have that blood come onto the sensor. The app can tell essentially the sensor what to do, and the sensor can give the data back to the app, and the app can pass the data to Julie. And at that point, we can sort of say yes, no, rather than just, we don't have to quantify it. We can also just qualify it and say that blood is there. Something that's quite intrinsic to our business model at Zimmer Peacock is, I described this sample onto sensor. Sensors driven by electronics. Electronics talks to the smartphone. Smartphone sends the data to the cloud, and we get the raw data up in the cloud. And now, actually, because we have Julie, Julie is a proprietary database. People do ask us, "Did you develop it?" Yeah, we developed it. It's all done in house. We bring the data in, we process the data, and we turn the data into information. And then we do have a API, application program interface, built into it. So you can actually call upon the data, and the list of commands in the API is just growing all the time because of increased users. Form factors. This particular individual is interested in particular form factors, but we have form factors here. I would call this kind of point of care. This form factor is something that we did with PBL, Plant Biosciences Limited, and JIC, the John Innes Center, and it's for continuum monitoring of nitrates. It's a very different form factor. This is a form factor. Very different again, same technology stacks, different form factor for putting into fish. The same technology using in strawberries, and then sometimes to make things really simple, this is a lovely form factor because obviously you have this smartphone the instrument itself, and then the sensor. So it's very compact, and that is probably one of the lowest cost ways of making a diagnostic or point of need type test. Just as a side note, we can put all of this in the same package and make it small, and I don't want to say disposable because of the PCB elements. I'm going to be careful with that statement, but we can essentially, because electronics have got so small these days, I mean, the sensors are intrinsically small. The sensing element here, for example, is really just this area here, and that's an object that's probably like 5 millimeters square. The electronics now have got so small. This is a sort of standard set of electronics from us. It's the same size as my sort of thumbnail. I've just put this object in here because actually, we do have to think about battery. Power is always a thing. And maybe at ZP now, I'm being asked more and more about power, and that's, as you develop, as you become part of the Internet of Things, as you become part of remote monitoring, you do have to think about power a lot more. So it's just a personal note to myself to think about power a bit more. So all I want to say here is that, if people are interested in detecting the presence of objects, or not objects, but samples like blood, really it's no issue. Blood does actually have quite a strong signal. Now, question number 2 is much more not in depth, but let's go for it. So I just want to discuss the process to manufacture a biosensor. So when I say manufacture a biosensor, at Zimmer Peacock, we do have the ability to make electrodes, and the ability to make electrodes can be through things like vapor deposition, or it can be through processes like screen printing, for example. So we do have lots of technologies for manufacturing at least low-cost screen printed electrodes. Now, I want to sort of dive in a bit deeper here and just talk about, if you are manufacturing a biosensor, there's the process, first of all, of manufacturing the electrode. And I'm essentially going to skip all of that. But I'm actually going to say, even if you manufacture an electrode, if that's the start of the process, then you're going to have to do, obviously, an IQC, an incoming quality control test on that. Now, at ZP, that IQC can be electrochemical. We have a system called Julie. We have parallel test stations, and we'll come in there and we'll electrochemically characterize the electrodes to make sure that they're within specification. Now, that specification is a kind of essentially a negotiation between the end user, let's say the company that wants those electrodes, and the manufacturer. In this case, it could be us. But that said, electrodes need to be IQC'd into the process. That we could also do a visual inspection, but everyone does a visual inspection. Everyone does it, but actually then they find that the electrodes don't function the same way. So visual inspection is not really good enough when dealing with electrodes that are meant to be used in an electrochemical biosensor or electrochemical sensor. Anyway, next process often when making a biosensor is to actually functionalize the electrode. And this can be done through some form of deposition. Here I'm assuming it's a kind of a robot, XYZ type robot is doing a deposition. That's the kind of way that we would do it, though we do have dip coating, electrochemical processes as well. At which point now, we would do another in-process test. Now, you might reduce the amount of testing with time. The more times you manufacture something, then the more refined that process can become, and then maybe the testing will become less. But at least the early days, you have to do more testing than you would do later on. But depending on the sort of manufacturing life cycle of where you're at, you probably do more testing at the beginning, and you can sort of turn that down over time. At the same time, we can also do visual inspection, and it's a bit more than just visual inspection, because we'll actually do sort of hyperspectral type analysis as well, and actually look at the polymers, and I will describe that on a slide in a minute. But you're trying to make a biosensor. Biosensors are often made, or at least are the kind of biosensors, there's often an electrode which gets functionalized. So the electrodes themselves need to be ensured to be within spec, that they would meet the criteria of the final application. Once you get through that IQC stage, now you can sort of do a functionalization stage, but actually even a functionalization stage, now you want to have a sort of in-process control, which could be electrochemical and a sort of a non-destructive visualization. The reason every time you test something, every time you do a part, it actually puts a cost onto the device, and so it has to be sort of a negotiation around what the product can actually afford in terms of costs. It's actually not unusual then in biosensing to have first layer and then a second layer. Now, at this point, that layer might actually that device might be completed, at which point we want to do an OQC. Now, this OQC is different because we are showing raw signal here, but it's actually raw signal as a function of concentration, and I will have a slide specifically on that. So the OQC would actually be could often be more of a functional test, and we can do non-destructive visualization, but everyone does non-destructive visualization, and it's not good enough to really capture issues. I think you actually have to do some functional testing as well, and so we would call that obviously OQC. I've probably skipped some steps here because now we're actually going. I've just assumed that we've gone into packaging, but you have to have SOPs and agreements and labeling descriptions. Maybe there's even there's something I'll touch upon as well. There may even be calibration factors going onto this packaging, but I can discuss that in a minute. And in fact, I think though it's very small, there's a little video playing just on this page. At one point in this video, we actually show that as part of the workflow, the application is actually reading a QR code. And this is probably important that when you're talking about manufacturing, you can have what's called batch-to-batch variation. Now, everyone says, oh, I want calibration-free devices. And I say that's great. You have to look at the history of glucose sensing. That's, glucose sensors is this archetypal electrochemical biosensor. They've been around, glucose strips have been around for now approximately 40 years. And it was only in 20 years that actually they went for calibration-free, and that was after they made billions of strips. So be careful with the claim, that we want to be calibration free. It can happen, but there's a cost involved with it. And I suppose in the glucose sensing world, they did it because eventually the manufacturing kind of caught up with what the market really wanted. They could have done it earlier, but there would have been a real cost. And then at that point, the market may not be able to afford that. So now I'll go a bit quicker now and talk about sort of things that we do at ZP. So I talked about IQC, incoming quality control. I mean, there's one thing you should know, that we do high volume testing. So it's not enough to just test, a handful of devices. We'll typically test, in things like 50, 100, 150 type of devices. Good thing is we've got Julie, so Julie can take all the data in and actually just spit out reports. And so we actually often with science and engineering, you can spend 1 hour doing the work, and you could spend 4 hours analyzing the work. Well, with this, because we've got Julie, we save rather a big chunk of time. So Julie allows us to see the raw data, and it can do statistical analysis on it, so that the QC manager can see this is get a snapshot of what's actually happening. It's also worth saying that Julie's obviously a cloud system, so if you're working with us, you can also have access to Julie and see the quality control data. I sort of skipped a step here I've just gone to OQC. So I said OQC is different because OQC, is probably more like functional testing. So here that we have tested some sensors at something like 0.5. I think there's an 8, there's a 2 in there, there's a 6 in there, there's some 4s in there. So we've tested at different concentrations. And again, Julie's actually able to analyze that and kind of come up with a calibration curve. We're able to do histogram type analysis on it. And we're able to sort of show here sort of match between predicted concentration, actual concentration, and look at our error bars as well. So Julie's pretty powerful because we can put the raw data in there. A technician, test engineer, I should say, really can do the testing, and all the data goes up to Julie. Now, I have talked about IQC and OQC and electrochemical testing and visual inspection, and there's packaging. But of course, all of this actually requires sometimes it's a service level agreement, but sometimes it's a framework agreement, and at least SOP. So it's not enough to say, I want you to, oh, people know this, I want you to manufacture this piece for us. There's actually quite a process. And what we do at Zimmer Peacock is we often do a sort of proof of principle manufacturing, where we'll run really there's alpha manufacturing, beta manufacturing, there's pilot manufacturing. So we sort of do an alpha run on this as a proof of principle in manufacturing, just to sort of run through this workflow and see what we've got essentially. I did touch on non-destructive testing. So non-destructive testing. So for example, this is quite a nice validation that we have some electrodes here that have no coating, 1 coating, 2 coatings, and 3 coatings. And then we're actually able to, even though the visual inspection is not so, the sort of visible part of the, let's say the light is not so useful, actually when we sort of enhance the images, we can actually see quite a distinct difference. And it's also that we're able to quantify it as well, that we can actually see those coatings and give them, features and actually quantify those features. And so depending on the coating, the features change accordingly, and that would then give us a sort of non-destructive handle on whether we've coated a surface or not. And that's quite useful in biosensing because it's non-destructive, and actually putting polymers on surfaces is or materials on surfaces is quite a common procedure, and it's non-destructive. More people do this non-destructive testing, but it really does have to be augmented with the electrochemical testing that is much more specialized at Zimmer Peacock, and Judy can both analyze the non-destructive data and the electrochemical testing data as well. So I'll summarize now and say, appreciate the questions. One of the questions this week is, can you test for the presence of blood? Yeah, blood does actually have a really strong distinctive signal. I mean, it's red. Look at it. It has a certain viscosity about it. It has some unique chemicals in it. So for us, it's quite a distinct matrix, or distinct sample, I should say, in nature for us. And then I put here the cost to manufacture a biosensor. I suppose the cost to manufacture a biosensor is, it's not the physical work often, it's actually the quality systems around the sensor that really kind of layer the cost on. So as I say, I like to do these videos live or live streaming because we get the real-time feedback. People are asking questions in the chat. So I apologize that I just don't have the internet connection here today. But thank you very much. And if you have any questions of Zimmer Peacock, don't hesitate to reach out to us. At the same time, I will put links underneath the video to pages that I think are relevant on the website. So thank you very much. Take care. Bye-bye.